Good day, my dear students. Today we shall talk about particulate nature of matter. My name is S.Adebayo. We shall discuss some basic facts about matter. The main objective here is to study the structure of matter, and we talk about the evidence of particle nature of matter, and we also talk about the simple atomic structure and molecules, the nature of the molecules and sizes. Structure of matter. We believe matter can be defined as anything that has mass and occupies space. All substances are made up of matter and are all acted upon by gravitational force towards the center of the earth. So when a matter such as piece of yam is cut into smaller and smaller bits, one will eventually find the smallest particle, which could not be divided further. Such particles are called molecules. Now, what I want to quickly explain here is that the smallest, anything that has mass rather, and occupies space is said to be matter. But the smallest particle that ever exists alone is the molecule. You know, there is a man called Dartin. Dartin was the one that first experimented some facts about matter. He discovers that matter is the smallest indivisible part of any substance. Whenever you pick any substance and you start breaking it further, you start to slice it, it will get to a particular point that you will no longer be able to break it down further. And that is smallest aspect is called the atom. But the smallest aspect that is capable of independently existing is the molecule. We shall talk about that. Matter can exist in the following state. We have matter existing in solid state, liquid state, and we have the gaseous state. The evidence of particle nature of matter. The fact that matter is made up of particles is evident from the phenomenon of diffusion and Brownian motion. So there are two phenomena basically we shall be discussing here that shows the fact that matter is particle in nature. And the first one is diffusion. The second one is Brownian motion. The random motion of particles such as smokes as a result of being bombarded by invisible air molecules is known as Brownian motion. The Brownian motion is that random movement. You can see when you have particles, like for instance, when you have fluids or when you have gases moving thereabout, you see the regular nature of movement of molecules of particles. Like when we have dust now, for instance, you can't predict the movement. When you have a dust or we have a choky area that we have a kind of movement of the particles of that dust, you see that the particles move in a random manner, in an irregular manner, in an unpredictable manner. Such movements of particles, such as smoke, as a result of being bombarded by invisible air molecules, is known as Brownian motion. So that is what exactly. So Brownian motion is typically irregular movement or unpatterned movement of particles of matter as a result of being bombarded by invisible air molecules. That is what we call Brownian motion. And in diffusion is the process by which substances mix thoroughly together and intimately with one another as a result of random motion of their molecules. When substances mix thoroughly together and intimately with one another as a result of random motion in their molecules, the direction of the molecules is in such a way that they flow from a region of higher concentration to region of lower concentration. That is exactly another way of describing or defining diffusion. Is the movement of molecules from the flow or from the region of higher concentration to the region of lower concentration. Okay, now let's talk about some other facts about diffusion. Diffusion is fastest in gases and is the least in solid. I want you to note that gas diffuse more. Gas can move there about more than in gases or in gas molecules than in solid molecules. Excuse me, than in solid molecules. So gas move faster in gases. Diffusion moves faster, or diffusion is fastest in gases and is very slow in solid states. So the rate of diffusion is affected by these factors I listed. The rate of diffusion is affected by the mass of the molecules. The mass of the molecules the lighter the molecules, the higher the rate of diffusion. Temperature also can enhance diffusion, density of the substance, the pressure, the concentration gradient. Other evidences of the particular nature of matter are there. I told you that we shall discuss mainly the diffusion and Brownian motion. That's an evidence of particle nature of matter. But there are other evidences which are osmosis. And osmosis means the movement of molecules from a region of lower concentration to a region of higher concentration across a membrane. That's the difference between the osmosis and diffusion. We must have been taught about this in biology. The movement of molecules from a region of lower concentration to a region of higher concentration across a thin permeable membrane. And law of definite proportion also talks about the particle nature of matter. You know, so in a nutshell, now we have diffusion, we have Brownian motion, we have osmosis, and we have the law of definite proportion. This all talk about particle nature of matter. Okay, let's go to the next slide. The atomic structure, the simple atomic structure. The atom is pictured like a cell, like an egg that has a yolk, a boiled egg rather, that has a yolk. Now, the yolk is more or less like a nucleus. And inside the nucleus, we have the protons and the neutron. And we now have the shell that around that nucleus to be electrons. So basically, the atoms is pictured to be having a nucleus, and look and see. So this is more or less a nucleus, and this is the electron. So inside the nucleus now, we now have the proton, and we have the neutron inside the nucleus. That is so we have the shell. The shell is the atomos shell. That is the outside of the shell. Like the atomos shell now is like the cover of the egg. When we boil an egg, we have to peel the cover before the white, and after the white there is a yolk. So the cover is more or less the atomos shell, and the white aspect of the boiled egg is called the electrons. That is the one that orbits around the nucleus, and the yolk inside it is now it's the nucleus. The shell is the electron. The yolk inside it is now the nucleus, which contains protons and the neutron. So an atom is defined as the smallest unit of a matter. I said that before, that can take part in a chemical reaction and is not capable of independent existence. So that is the difference between this one and molecule, is that a molecule is defined as the smallest unit of a matter that can take part in a chemical reaction and is capable of independent existence. But the atom is defined as the smallest indivisible matter that can take part in a chemical reaction and is not capable of independence. So molecule is capable to exist independently, and atom is not capable. Look at hydrogen now. Hydrogen gas, yeah, that's H2. That is a molecule, hydrogen molecule, H2 gas. H does not exist naturally. H. So that, well, H is an atom of hydrogen, but still it is the smallest unit of hydrogen, which is H. But the H2 is the gas, which is the one that is capable of existing. Every atom of a substance is believed to have a nucleus of about 10 to the power minus 15 meter in diameter. The nucleus of an atom contains neutron and proton, called nucleons. Yeah. The nucleus of an atom contains neutron and proton. The joint name for neutron and proton is nucleons. Don't forget that. So nucleons is the joint name for protons and nucleus or neutron. A nuclide is a particular species of atom, one whose nucleus contains a specified number of protons and neutrons. The atomic number, I think I talked about this before. Atomic number is the number of protons contained in the nucleus. And atomic number is equal to the number of electrons whenever that thing is neutral. I discussed this later before now. Atomic number is number of the proton of any atom. For instance, sodium have 11 as atomic number. Actually, it actually means number of proton in a sodium is 11. But atomic number It's also the number of electrons in a neutral element. Whenever a particle is neutral, the number of proton is equal to the number of electrons. So the atomic number can also be said to be the number of electrons if that particular atom of element is neutral in nature. But whenever the atom of element is not neutral again, the number of electrons and protons are not equal. So therefore, the atomic number is only the number of protons, which is the atomic number rather. So the mass number A is the number of nucleons. So mass number is the number of nucleons. That's the number of protons by number of neutrons. That's what we call the mass number. So isotopes are nucleus having the same atomic numbers but different mass number. So whenever we have an isotope, that means that is the same element having the same atomic number and different mass number. An example of that is chlorine 1735 and chlorine 1737. They are isotopes. You can say that they are the same atomic number but different mass number. Isobars. The isobars is nuclide or a nuclide having the same mass number but different atomic number. You can see the argon 18 and calcium 40, calcium 2040 and calcium 1840. They are isobars. Why? They are when we have nuclide isobars. When we have isobars, they are nuclide that have the same mass number but different atomic number. Now let's look at the table below shows some basic properties of particles of atoms. Most of the textbooks have this. You can check your textbooks. These are the basic properties of and look, the charge here is one of the main things I'm really interested about. A proton is positive 1 charge, electron is negative 2 charge, and the neutron is neutrally charged, 0 charge. Don't forget that. So there are some important points that we have to know is that protons and neutrons have almost the same mass. That's rubbish. Proton and neutron, they have almost the same mass. Look at the mass here. It is a mass. Proton, look at the mass. They have almost. Proton and the neutron. Sorry, proton and the neutron. Don't mind me. Let me just clear it off. Sorry. Proton and the neutron have almost the same mass. This is what I'm saying. This one and this one. You can see. And this one and this one. Okay. And that's another one. Electron is approximately 2,000 times lighter. Electron is 2,000 times lighter than either of the proton and the neutron. You can see that. So protons and neutrons carry charges of equal magnitude but opposite charges. So you can see proton is +1, the electron is -1. So the same charge but opposites. By neutral is 0. That's what main thing that you should know. Now molecules and their structure and the size. All matter is made up of tiny particles called molecules. These molecules themselves are made up of tinier particles called atoms. Atoms aggregate together to form molecules. Both molecules and atoms are too tiny to be seen with our naked eyes. So 1 mole of every substance is believed to contain 6.02 × 10⁻23 molecules. So 1 molecule of a substance could be found from the combination of 2 or more elements of that substance. Hence, we define a molecule as the smallest unit of a matter that is capable of independent existence. That's exactly where I'm going to. Molecules is the smallest unit of matter that is capable of independent existence. So this means that a molecule of a substance could exist alone. A molecule of any substance can exist alone. It's the atom of any substance that cannot exist. Some atoms cannot exist alone. Like hydrogen gas I've just talked about now. Hydrogen gas exists as H2. It does not exist as H. Oxygen gas exists as O2. It does not exist as O. So oxygen O2 is the molecule of oxygen. But oxygen O is an atom. The atom of oxygen cannot exist alone independently. There's nothing like O, but there's O2. So that's exactly what I'm trying to explain there. So an atom is defined as the smallest unit of matter that can take part in the chemical reaction, and it's not, you can say, it's not capable of independent existence. But a molecule is the one that is capable of independent existence. So it's a substance which consists of only one kind of matter. An element is in any substance in which everything could be built up. and cannot be broken down into simpler substance by any chemical means. Now, these are simple evaluation questions that I want you to look at. On what condition will a body be considered a matter? In what state of matter is diffusion fastest or slowest? What is the direction of flow of molecules, flow of molecules during diffusion? I want you to look at these questions and write them in your assignment book. We shall call for those books anytime from now, any moment from now. So they are from week 1. There are some evaluation questions that I instructed you to do. So make sure that you do it. Week 1 assignment, do it. Week 2 assignment, do it. Week 2 evaluation, do it. Make sure that you do it. Whenever we call for it, you should be able to provide the evaluation book, which is the assignment book. The other ones are here. That's the second page of the evaluation questions. So I will be seeing you in our next class to discuss further on the particular nature of matter 2. Until then, don't forget to subscribe to this channel, subscribe to this YouTube channel, so that you can get updates of anything that is going on in your class. Thank you very much and have a blissful day.